SpaceX's Starship isn't just another rocket, it's a revolution in space travel. Instead of a disposable rocket, Starship is designed to be fully reusable, like an airplane for space. The goal? Make space travel routine, affordable, and accessible for everyone, not just astronauts. Imagine building cities on Mars and bases on the Moon, all with a vehicle that can fly again and again. Every rocket before this, even Falcon 9, throws away parts. Starship brings everything back. That's the key to slashing costs. Reuse the hardware, just pay for fuel and crew. Starship is massive, taller than the Saturn V, made of stainless steel for strength and heat resistance. The system has two parts: the Super Heavy booster for liftoff, and the Starship upper stage for carrying people and cargo. Together, they can haul over 100 tons to orbit, enough to launch a whole space station in one go. The challenge isn't just getting to space, but coming back safely, ready to fly again in days. This is a leap in engineering, aiming to make spaceflight as routine as air travel. The ambition is wild, but the potential is world-changing. Starship's design could open a permanent highway to the stars. It's not about flags and footprints, it's about building a future in space. The engineering hurdles are enormous, but so is the vision. We're witnessing the birth of a machine that could change humanity's destiny. The stakes are high, but so are the rewards. Starship is the boldest step yet toward making space home. The Super Heavy booster is the muscle, powered by 33 Raptor engines, all firing in perfect unison. Orchestrating that many engines is a colossal challenge. One misstep, and the whole rocket could fail. Each engine has its own pumps, valves, and computers, all needing to work together flawlessly. The plumbing is a maze, feeding super-chilled methane and oxygen to every engine. The structure must survive intense vibrations and forces without tearing itself apart. After launch, the booster flips, reignites some engines, and flies back to the launch site. The plan: catch it with giant robotic arms, Mechazilla, something never done before. Every phase, from ignition to landing, is an engineering puzzle. The booster's job isn't just power, it's precision and control. 33 engines, one symphony, every note must be perfect. If they pull it off, it's a new era for rocketry. This is the heart of Starship's reusability. The Starship upper stage is built for orbit, and for coming back. It has 6 Raptor engines, 3 for space, 3 for landing on Earth. The real trick is re-entry. Instead of nose first, Starship belly flops, using its surface and 4 flaps to slow down. It's a controlled fall, bleeding off speed with the atmosphere, not fuel. The software must keep the ship stable with constant flap adjustments. Just before landing, Starship flips upright, fires its engines, and aims for a gentle touchdown. The heat shield, thousands of ceramic tiles, protects against re-entry temperatures. Any missing tile could be catastrophic, as history has shown. The flip and burn landing is a high-stakes move, but essential for reusability. Every part must work perfectly, or the mission fails. It's a ballet of physics, software, and hardware. Starship is redefining how we return from space. Building Starship means solving 1,000 problems, not just one. Fuel leaks are a constant battle. Cryogenic methane and oxygen can make metal brittle and seals fail. Early tests saw leaks cause fires and explosions. Finding every leak is painstaking but vital. Engine heat is another challenge. 33 Raptors generate immense thermal energy. SpaceX added insulation and vents to manage the heat and protect the engines. The heat shield's ceramic tiles are heavy and brittle. Every kilogram counts, and every tile must stay put. Vibrations can crack or dislodge tiles, so SpaceX developed new adhesives and flexible layers. Hot staging, igniting Starship's engines before full separation, meant redesigning the booster's top with a vented steel shield. It's a brutal but effective solution to a tough physics problem. Every fix is a step toward reliability. The work is messy, but essential. Starship's challenges are as much about details as big ideas. Every solved problem brings us closer to routine spaceflight. This is engineering at its toughest. SpaceX's secret weapon: build, fly, fail, repeat. They test hardware fast, learning more from a single flight than endless simulations. Every explosion is a lesson, not a failure. Their rapid, iterative approach drives innovation at unmatched speed. Advanced software controls the engines, using differential throttling for precise steering, even if a gimbal fails. For re-entry, they've toughened the heat shield tiles and improved their attachment. The launch pad now has a water deluge system to handle the Raptor's fury. For hot staging, they cut a vent in the rocket. Simple, direct, effective. In-space refueling is another breakthrough. Starship can transfer cryogenic fuel in orbit, a first at this scale. Every new problem gets a new tool, from purging lines with nitrogen to inventing new alloys. SpaceX is rewriting the playbook for space engineering. Their toolkit is built on real-world results. That's how they're making Starship possible. Starship's journey is a masterclass in learning from failure. Early prototypes exploded during tests, especially during the tricky belly flop and landing. Each fireball brought crucial data about flaps, engines, and structure. The first full-stack flight in April 2023 cleared the tower but failed mid-flight, destroying the pad, yet proved the concept. SpaceX immediately built a stronger, water-cooled launch pad. The second flight saw all engines fire and hot staging succeed, though the booster exploded during return. The third flight achieved a full ascent, payload bay door test, and in-space fuel transfer before losing Starship on re-entry. The fourth flight was a breakthrough. Both booster and Starship survived, each making controlled splashdowns. In just over a year, they went from explosions to successful landings. The pace of progress is astonishing. Each test proves the system's core architecture. Starship is moving from wild idea to working reality. The future is arriving fast. Why does this matter? Because every solved problem brings us closer to making humanity multi-planetary. Starship isn't just a better rocket, it's the key to opening the solar system. For NASA's Artemis program, Starship will land astronauts on the moon and bring them back. Its huge payload means bigger crews and more supplies for permanent lunar bases. Recent test flights prove Starship can deliver on this promise. For Mars, Starship's refueling in orbit is essential. No other rocket can carry what's needed for a colony. Its cargo bay can deliver habitats, rovers, and supplies for the first human settlement. Without Starship, Mars remains science fiction. Every test, every landing is a step toward that future. SpaceX is building the ship that could carry us to new worlds.